Hi, everybody. Welcome to today's webinar on Path Explorer AI. I'm Erin, Business Development Manager here at Softry, and with me is Matthew Dickey, our Training Manager. Today, we're going to do a live demonstration about using Path Explorer to quickly identify optimized road locations between 2 points, A and B, and showing you how you can minimize your earthwork costs and save a whole bunch of time in your preliminary planning. Then we're going to show you how to take that initial alignment and convert it over to a geometric road design. So let's start with a little bit of information about what Path Explorer is. It's a new AI-based tool that's inside of our terrain module. It's part of the Softry Optimal add-on, and it can help you figure out where to put your roads and corridors, sort of landscape level with the terrain. So using this technology, you can quickly explore millions, literally like tens or even hundreds of millions of different possible road locations to find low-cost, constructible candidate solutions. These solutions are done with a simplified road prism, so we're not looking at the real specifics of your cross-section, just your width, and a simple trapezoidal prism. And we're able to take into consideration your cut cost, your fill cost, your surfacing costs, as well as some of your key design constraints like your minimum horizontal curvature, min and max grades, cut slopes, etc. In addition to that, we can leverage our construction zones editor that comes with Path Explorer in order to account for different hydrological or geotechnical, or even say, for example, right-of-way constraints. We're able to account for those. So how is this useful? Now, looking at the screen here, I think just based on our audience, I know many of you can probably look at this terrain and really quickly visualize where to put a road. But how do you know that you aren't missing anything? And how do you know that that's the best option? Well, this is actually the project that we're going to be demonstrating today in this webinar. So I encourage you all to remember your guess and then, yeah, take a look at it once we get into that live demo part. So maybe you can't visualize some of the route options right away, or you want to do some more diligence. So there's a few other methods that people use to figure out where to put a road. Maybe they're looking at contour maps and ortho photos. Maybe you're out exploring options in the field, or what I would like to call guess and test designing. So loading up a geometric design software like RoadEng and exploring different options in the software. Now, all of these take considerable time. And what Path Explorer really tries to do is reduce this upfront time spent trying to figure out where to put your road. It's giving you really fast, optimized options that minimize the earthworks, meet your constraints, and can allow you to add that time back into the design process elsewhere through different value adds. So what today's about, we're going to show you how to leverage Path Explorer to jumpstart your greenfield road design process. And this is really all about changing the question from, looking at your landscape and saying, where should I put my road, to why shouldn't I put my road here? So being able to leverage those great results from Path Explorer, narrow in your landscape level selection of that suitable road. And of course, Path Explorer is looking for low-cost, optimized earthwork solutions that meet your constraints. So you're also going to likely save cost as well in this process. Now, quick caveat, I do keep saying the word road, but this really is not just about roads. This applies to trails, pipelines, overland conveyors, even something like a wildfire line break. Path Explorer can rapidly explore suitable locations for those types of alignments. So it's basically any type of linear infrastructure. Now, before I pass it over to Matt, I just wanted to highlight a couple limitations of the tool. So first off, I just want to remind you, this is just a tool. It is not, to by any means replace your professional opinion. This is just a tool for your tool belt. And although it is really efficient and fast, it's not a full detailed design at the click of a button. There's a few more buttons to press to get there. But what it does do, it does really well. So it does a thorough assessment of your given parameters. It performs lightning fast, and we're talking about like usually under 5 minutes for a path exploration. You can account for more than earthworks. So it's really flexible in that regard and leveraging the construction zone editor. It enables iteration and allows you to really quickly compare options. So you can imagine, especially if you're in the consulting side, being able to give your clients, look at all these options we were really rapidly able to iterate on, and giving them, details. And then the last piece, which really connects nicely into today's webinar, we're going to show you how it integrates with RoadEngine's location module, so you can take that initial path exploration and turn it into a full geometric road design with a few extra clicks. Not one click, but a few clicks. Anyways, that's it for me. I'm going to pass it over now to my colleague, Matt, and we'll get into the software. Okay, Matt, I can see your screen.
Excellent. All right, so I'm going to dive right in, and unlike a lot of our webinars, I'm going to start out with things already set up. So I've already brought in my topo data. I've already modeled my streams with our hydrology tools. In this case, I brought in a shape file with my the property boundary that I'd like to work in, and we brought in an ortho. So we've got this set up, and as Aaron introduced, we are going to go from point A, which is down here, up to point B. So this line that we're starting with is a line that was kind of laid out traditionally, and we're going to see if we can do better. So first step of using the Path Explorer tool is going up to the Optimization tab, clicking the little Path Explorer AI button, and we're going to configure our design parameters to match what we'd like to adhere to. And this one, I'm going to keep it a low speed road, so 35 meter radius curve. It's going to be just a industrial road. We're going to keep it 9 meters wide with our simplified cross section. I'm going to let it be steep, but not super steep. So we're going to max it out at 18%. And I want 5 options. So it's going to give me however many options I tell it to within I think a ceiling of 10. So it will adhere to those design constraints. Now, what it's going to consider as it searches around this area is earthworks costs. So we could run with the default, or we can change it to something that better suits our expected unit rates. So I'm just changing those here. And if you've seen me run through this in other examples, well, a lot of the time I'll just run with that and get solid results. But in this case, there's a few other things that I'd like to account for. So I'm going to go into my construction zones, and I'm going to account for costs and areas that I can't go that deviate from either these default values or just areas that we want to avoid. So I'm going to click New. And we have the option to add in 4 different types of construction zones. So we have no-go polygons, no-go polylines, polygons, and polylines. So I'm just going to open up polygons here, and I'm going to just grab in something arbitrarily. So if I wanted to tell the software that we had an area that has different unit rates, so we can say, well, through this section, we expect there to be shallow bedrock, and we can crank up the excavation cost for that. And the software is going to consider that as it searches around for what we're dealing with. Or we can change our design constraints for a specific area. Now, I'm not going to go with a polygon in this case. What I want to consider here are mainly my streams. So we've got our earthworks costs, but obviously if we have to put in a bunch of pipes for these different crossings, well, we should account for that. And again, if you've seen me click around in this and other webinars or videos, well, a lot of the time I just apply a blanket cost to all my streams and get reasonable results. But you don't have to. You can split them out for different costs. I'm going to do that here, and I've just got them earmarked. So these ones I'm going to say, well, the crossing cost for crossing these features is going to be $1,000. And I'm going to go in here and we'll say, well, the crossing cost for crossing these features is going to be $2,000. And we'll continue along through here. And say this one's $5,000, and really all I'm doing is just acknowledging, well, this big stream at the bottom here is going to cost a lot more than one of these little tributaries up in the top of the watershed. And this big stream in the bottom, I'm going to say it's going to cost $10,000. So we've got some extra costs applied. But aside from just saying something's more expensive or cheaper, we might also want to tell the software, well, I don't want to go there. So for that, we've got no-go polygons and no-go polylines. So in this case, well, I don't have one, but we could have an unstable area that we wanted to avoid, and we could add that in as a no-go polygon. But I'm going to use no-go polylines, and I'm going to apply that to this stream that I have highlighted in red here. So that we're at the confluence. There's some kind of gnarly stuff going on. If we can avoid it, let's just tell it to avoid it. And then the other thing that I'm going to add in as a no-go polyline is my property boundary. So I've got this polygon that goes around the search area that I'd like to consider. And well, in this case, I don't want to cross that line. It might be a polygon, but we can treat it as a line just as easy. So we're going to add that in here. So I've got two no-go polylines. We'll hit OK, and our construction zones are set up. Now, we're going to go over to our source and destination. So another thing that deviates from just running with the default settings here is we can account for the approach direction that we want to come into our destination, so that point B, or the direction that we want to leave from our point A. So in this case, I want the new road to be aligned, kind of tapering in with the existing pointed that way. So we'll set that. And then for our destination, well, this is an industrial road that may go ahead further later, and I want it to be pointed in that direction when we come into that point. So we'll run with that. And of course, we're going to hit OK. And from a problem size standpoint, it's a big problem. So it's not going to get solved instantaneously, but for what it is, considering it will get solved fairly quick. So we're going to have a few status updates through here. So for the first little while here, it's just going to tell us that it hasn't found a solution yet. And then, well, after a little while, hopefully not too long, it's going to tell us that, well, it's found a solution, but it's still improving. And then it'll find several solutions fairly quick.
So while that's searching, this is kind of your last chance. Visualize where you thought that road was likely to go, best routes. Yeah, hopefully the results aren't too much longer.
Yeah. And so now it's saying we found 5 paths, and it's still searching for better solutions. So.
And I love how a minute feels extremely long when you're doing this live, but yeah, the reality is, yeah, this is really, really fast in terms of problem size. This is, you know, looking at tens of millions of options right now.
Yeah.
But it does seem uncomfortably awkward while we sit here and wait. So if you have any questions, perhaps we can grab one out of the chat.
All right.
Oh,
and actually,
never mind. No time for questions.
Yeah. So it's saying unlikely to improve. We'll hit cancel. We'll hit OK. And we can see we've got, well, a few different solutions to run with. So we are going to run with those. Now we are going to, well, we could, I guess, obviously just look around and kind of make some, make our own opinion on what ones we'd like to pursue. Or we could look at it and say, well, based off the costing information we've applied here, what one is what? So, or how much does it cost in terms of the metrics that the software is looking at? So I've just selected feature by name. We can come in here and we've got all our Path Explorer features at the top of our list. And then we've got a number after that XPath underscore. So this one's my cheapest at $114,000 given the unit rates that we've run with. And well, this one down here is the most expensive of the group. I'm gonna run with that one. So we can see we're going, well, the one highlighted in magenta goes across up here and then crosses and up that draw to our destination. So I'm gonna hit save. And we are going to switch over to location.
While that's saving, Matt, I've got a non-clicking question for you. We have an audience member that would like to know what type of computer you are running and some basic specs on it.
Basic specs. It's a i7 processor with 16 gigs of RAM, so it's not a supercomputer, but yeah, it's decent. Yeah, just a standard laptop.
Yeah, and I think that kind of goes with our company policy was we're never going to demonstrate anything on a super machine for you guys. It's all basic computers. The programmers get the fun ones.
So I'm just going over to location here. I'm referencing my terrain file just as I, well, as we would if we were setting up any other location file. Here for my initial alignment, I'm going to use my, well, that feature that we have selected. So I'm going to bring that in as my starting point. And there we are. Now things are set up, but there's a few things, well, we're going to want to transition to having this a little nicer as we go into more of that classic design space. So first thing, we've got a polyline, so just a series of lines and vertices. And I want to have a proper alignment with curves and tangents there. So I'm going to go up to our corridor button. I'm going to run our new polyline to alignment tool. And here we'll set our minimum radius and max offset distance. We'll hit OK. And again, we've got something where we're going to have to, well, watch it think for a few moments. But what it's doing is it's trying to reduce the number of curves for this alignment within that tolerance we have applied. So it's reducing that, and we can let it go. Usually it doesn't take too long. And now instead of having, well, a series of vertices and lines in that polyline, we've got proper curves and tangents. So next item that we typically address is, well, our cross-section geometry. So the template I have applied here is the one I want, so I'm good with that. It's my default template, but we easily could go up to our templates and configure it however we'd like. And now I want to get an even more optimized alignment where we're considering more. So when we ran Path Explorer, it's considering a simplified cross section. We're going to consider the real cross section. We're also going to consider our material movement. We're going to do that in our vertical optimization. So Project Explorer panel, we're going to go in here. We're going to tell this, well, let's sample along our alignment. I'm going to put in my design constraints, so the same ones that I used before. And at the start here where we tie into that existing road, I'm going to just tell it to, well, use that elevation. We'll hit process, and once again, we wait for, well, it shouldn't take long, but yeah, not instantaneous. So it's going to sample along our alignment, and then it's going to fairly quickly figure out the optimal vertical alignment given the constraints that we put in there. We'll hit OK. And we've got, well, a proper vertical alignment here now. We can see we're not just road set on the ground, we've got our proper cuts and fills, and can move along here. We've got our alignment out here at the end. We're very close to balancing in the grand scheme of things, so we are, yeah, very, very tight, and we can look at our volumes down here. So I'm dealing with about 4,700 cubic meters of cut. As you'd expect, we can throw in our pipes if we'd like to add in a culvert. And yeah, of course, configure that to whatever size and orientation we'd like. We can do that for all our pipes if we want, but I'm gonna skip the extra clicking. It's just a matter of doing the same thing over and over again. And when we're happy with what we've produced, we can switch over to our multi-plot, and we can bring in, well, either a pre-formatted chapter, or we can grab a book or our own chapter that we'd like to work with. And I'm going to just skip here. I've got a few dead links, and yeah, we've got our drawing put together in a matter of minutes. Let's move a couple things. And that's that. That's the gist of it. If we want to take it out for construction staking, file, save as, choose whatever format we'd like. If we want to take it out for field review, we can file, save as, save this out as a Venza, and we can take this to the field as well. So that's my spiel.
Awesome, thanks, Matt. So that was a little bit over 15 minutes, but we went from kind of, yeah, imported LiDAR data, having a terrain with that, through to a preliminary road design and construction documentation. Maybe Matt, you could put the 3D view in the terrain up just so they can, yeah, reevaluate how they did in terms of seeing if they, yeah, saw the same route that Path Explorer was able to find. So I'd love to transition into our Q&A. I know we're only have 6 minutes left, but I'm happy to go a little bit longer here. So Matt, your first question, where did you get your streams from?
All right, so the streams, I just used our hydrology tools. Yeah, and I've got a few here that I've called out the costs, and just to make it easier for me to stay organized for this. But let's see here. Yeah, I'm just going to get rid of all the streams except the ones that I've changed the name for, but we can rerun that tool. So if we increase our drainage area here, the streams are going to start lower in the watershed. So yeah, it's really just a matter of going up here, clicking that button, and there's all the streams and ponding areas.
Awesome. Okay, I feel like the next couple questions are all interconnected. So this particular question is relative Queensland, but it says in Queensland we have acid sulfate soils that require expensive handling, almost like contaminated soils. How can we account for that? And I think connected to this as well is optimization within a given polygon.
Yeah, so there's well, acid rock stuff. We can tackle it by, well, one, if it's just certain areas that you're dealing with, avoidance is probably the best strategy. And with that, it could be, well, I absolutely don't want to go there, or it could be that if I go there, it's going to be really expensive. So if it's the only way, I'll do it, but I don't want to. So from a polyline to alignment, Path Explorer standpoint, I'm just going to arbitrarily create a feature here. So if that was identified as metal leaching and acid rock potential, well, we could say new. We could do a no-go polygon, which would be absolutely don't go in that feature. Or we could say, well, that polygon is going to be really expensive. And what did I call that? Oh, expensive. So here we could just crank up the costs per excavation, and well, then we'd really likely avoid that altogether if we made it obscenely expensive. But if it was the only way, it would still go through that. The other side of that would be when you're doing your vertical optimization, if you are going through an area like that, you could make it that the excavated material that comes out of there is not suitable for fill anywhere along your alignment, and you could designate that to go to a spoil site for treatment, or have that material only assigned through a specific range and keep it outside of, well, spreading the contaminant outside of its natural area. Or you could say no cut, so minimum embankment depth. There's a bunch of different strategies that you could use with constraints and whatnot to get around that. So all sorts of flexibility for different situations. The last part about optimizing within a polygon. So that's what I did here when I made this. This is my property boundary. So I've said, well, stay within this feature. Now here, if it's somewhere we don't want to go into, we'll usually set it as a polygon, but we can treat a polygon as a polyline, and that's where, while we're starting within it, we don't want to cross this line, so this line is a no-go polyline. In this case, no-go polyline, despite the fact it is a polygon boundary. Oh, hopefully that answers both of those questions.
Awesome. Okay, let's do a few more. Your next question is one that I was anticipating that we were going to get, which is, what's the procedure if we wanted to connect 50 to 100 points / wind turbines? I wasn't necessarily expecting that number. I was anticipating a wind farm question though. So Matt, do you happen to have, something that you can talk about A to B, B to C?
I don't have something special right off the cuff, but I'll throw something together here, and bear with me. This is just kind of on the fly. So just drawing in a feature. So if we wanted to go from here, and I'm just kind of arbitrarily picking a potential junction site to say over here, we could. It's not going to solve the network in one go for you, but you can solve A to B, B to C, or you can string them along. So I could very easily put that at the end of this if I wanted it to be continuous. So here I've got that B to C. It does save all your settings. With this, well, I don't want to have that property boundary. Well, I want to be able to cross it because I'm going from one side to the other of it. So I'm going to remove that. Now it's also going to save my direction constraints, and so in this case I want it to be point it any which way that way to start. And when it comes in, we want it to come from this direction. And I don't want to remove those existing points, so I can keep those as options to get to point B. And yeah, we run it and just kind of incrementally work out. So yeah, a series of A to Bs rather than all in one go. But yeah, totally, well, certainly beats doing it any other way.
Awesome. Okay, next question. Well, this one just solves in the background here. Can the tool be catered for Australian road standards?
Yeah, totally. So our road edge as a whole isn't fixed to a specific set of standards, so it's all customizable. You can change your cross-section geometry, you can change your road class specs, etc., to meet whatever standards you'd like to follow. And with that, it's not something that you have to set up every time. So for example, my cross-section geometry, just this gravel road, I was comfortable to just run with that, well, because I've got it set up to meet my default. So we can customize our cross sections, our curve specs, etc., and save those out, save them as our normal.tpl in the cross section case, and then when you open the software, that's what's there. So yeah, it's set it up. Don't worry about it unless you want to deviate from it, and away you go.
Next question is actually going back to your hydrology tools that we gave that little sneak of how you got the streams, which is, can we do catchment areas as well?
Sure. So I've just got a current point selected here. Let's go over here. So watersheds will give you the kind of the main drainage breaks for the whole surface. So catchment areas we'll want to run with drainage area tool. We can run it to features or series of features, or we can just run it to a current point. I'll run it to our current point. And we'll get the drainage area to this point here in a moment. And there's, kind of just given a quick overview. There's all sorts of flexibility in the tool. We can account for hydro enforcement if you've got existing road prism that you've got to culvert through. It's a pretty slick, pretty fast tool. So we just ran that and we can see we've got our drainage area of 12.6 hectares. So yeah.
Okay, helps if I unmute to ask the next question out loud. The next one is, where is it? Can the software run multiple optimizations at one go, or analysis is being done just one at a time?
Yeah, so one at a time, but at the same sense, it's really looking at, well, as Aaron introduced, thousands to millions of different possible solutions while it's doing that. And yeah, so it's going in one go. There's an option to do some of the, I think it's the horizontal or the vertical optimization can be, let's see. I'm not going to have much for, we can run that on multiple alignments. I've just got one here, but you can do that in, I guess, series. Set them up to run one after another. Yeah.
Okay, next couple questions look pretty similar, which is, how can I export the alignment out to 12D? And the other one that looks pretty similar to this is, can the alignment and vertical profile output be imported to Autodesk Civil 3D for further detailed design?
Yeah, okay. Save as. We can drop down here, and the most common format to use for that is going to be land XML. So it's going to preserve your alignment as a proper alignment with curves and tangents, and preserve your surface as the full tin. So yeah, land XML is the nice kind of catch-all for both of those. But if you want to export to DWG, DXF, DGN, etc., there are options to export to those other formats too.
Excellent. Okay, let's do one last one. This question, how does this tie in with vertical and horizontal quantity optimization? So in the location module, and would you run Path Explorer, then iterate on the vertical and horizontal optimization after you've assigned a cross section?
Yeah, so the software itself is set up to be I guess the Path Explorer is set up to be a front-end tool that we refine later. So it is totally something that, well, the workflow that we covered here with the start in Path Explorer, take it over to location, and run with it there is the most common workflow. If there's something that you want to adjust, well, you're not stuck with it. So we can move this around manually. So, and everything updates in real time. Now, as we're moving our horizontal alignment around here, well, suddenly the vertical optimization that we ran is no longer current. So we can, well, just come up here and rerun that vertical optimization. So yeah, you can iterate. It's one of those things usually that you'll Path Explorer into location, polyline to alignment, and then, well, kind of usually a quick sanity check and just vertical optimize it. But then if you find you want to change your cross section for specific ranges or change different ground types for specific sections, then absolutely go for it. Add whatever you'd like to add in there. And then when you have everything that you want to account for, you can redo that vertical optimization. It's going to account for all the complexity. Yeah.
And with that, last question, I feel like it's a good one to wrap up with, is will this session be recorded and can it be circulated to the participants on the call? Yes, it's definitely being recorded, but then I'm going to give you my disclaimer. Matt and I foolishly committed to doing this 3 times in the next 24 hours, just to, be able to have live conversations and answer live questions with people in different geographical areas. So I see a huge contingent of South Pacific, Australia, and New Zealand. So it's really nice to actually interact with you folks in this webinar. So we're going to be doing it again 2 more times, and we're going to pick the video that we think we did the best in. With that, thank you guys so much for joining us. I hope you enjoyed it. Hopefully had a little bit of fun with the interactivity of trying to figure out the route on your own. And look forward to talking to everyone again soon. Have a lovely rest of your day.
Cool. Thanks, everyone.